All right, so you're building the future with AI. That's incredible. But here's the question that should keep you up at night. How do you actually protect that amazing innovation? Today, we're going to open up the strategic playbook for patenting deep learning models.
I mean, think about it. You've spent who knows how many hours creating a revolutionary AI. It's smart, it's powerful, but here's the $1 million or maybe $1 billion question. In the eyes of the law, is it a real protectable asset? Or is it just an abstract idea, kind of floating out there in the digital world? This is the core challenge we're going to tackle.
And to really get it, you have to understand that patent law, well, it was built for a totally different era. On one side, you have a physical machine. It's tangible, it's concrete, you can touch it, clearly patentable. But on the other side, a mathematical formula. The law looks at that and says, nope, that's an abstract idea, and you just can't patent those.
And that brings us right to the heart of the issue, doesn't it? Your deep learning model, it feels a little bit like both. It's this super complex system, for sure, but underneath it all, it's built on algorithms and math. So where does it actually fall on this spectrum? Figuring that out is everything.
This is what a lot of people call the AI patent paradox. You've created something incredibly valuable, but the very engine that makes it run, the algorithm, is often what patent offices will flag as an unpatentable abstract idea. It's a huge, frustrating hurdle for anyone trying to innovate in this space.
But, and this is a really important but, there is a way through this paradox. The absolute core strategy is all about transforming your abstract algorithm into something the law can see as a concrete, tangible invention. It's not about changing the tech. It's all about how you frame it. Let's dig into how that works. Okay, think of your algorithm like a recipe. You can't just patent the basic idea of baking a cake. That's too general. But what if you invent a brand new, revolutionary process for making a gluten-free cake that tastes amazing and stays fresh for 2 weeks? Now that you might be able to patent. See the difference? The innovation isn't just the recipe. It's the specific, valuable dish you create with it.
So, the path from abstract to concrete really boils down to these 3 steps. First, you have to link your algorithm to a very specific application. We're not talking data analysis. We're talking a system for real-time fraud detection in credit card transactions. Second, you have to prove there's a technical improvement. Is it measurably faster? Is it more accurate? Does it use way less computing power? You need to show that. And third, you gotta highlight its real-world utility. What actual tangible problem does this thing solve for people? And this quote just nails it. The entire focus of your patent application can't just be about how cool or elegant your math is. It has to be about how your model takes a real-world process and makes it fundamentally, demonstrably better. That shift in perspective is the whole game. So that's the core strategy, right? But protecting your AI, it goes way beyond just that main algorithm. To really build a strong case, you have to look at the entire system and pinpoint what makes the whole shebang unique. This is where you have to get really specific. Ask yourself, what about my model is genuinely new? Did I design a completely novel neural network architecture? Maybe your secret sauce is in how you pre-process the data before it even gets to the model. Or hey, maybe you came up with a game-changing new training method or a brilliant way to handle messy, unstructured data. All of those things can be patentable elements. And let's clear this up because it's a super common point of confusion. You cannot patent a dataset. Doesn't matter how valuable it is. But you absolutely can patent your novel method for processing it, for filtering it, for learning from it. The innovation is in the how, not the what. You know, in a field like AI that moves at lightning speed, timing is absolutely everything. A really smart strategy is to start with a provisional patent. Just think of it like planting a flag in the ground. It secures your filing date and gives you a whole year to keep refining your model. Then you file the full non-provisional application to get the official review started. And because AI models are never really done, you can use what are called continuation patents to protect new features as your model evolves. It keeps your whole IP portfolio fresh. Okay, so innovation is global, and that means your intellectual property strategy has to be too. But here's the catch. If you have global ambitions, you have to understand that patent laws are not the same everywhere. What gets approved in one country might get flat out rejected in another. Just take a look at this. In the US, like we've been saying, the biggest hurdle is proving your invention is more than an abstract idea. But hop over to Europe, and they're looking for a clear technical effect, a tangible improvement to a technical process, like making data transmission faster. Then you go to Japan, and their framework is different again. They want to see a technical idea utilizing laws of nature. They're all really just different lenses for looking at the same fundamental question. Is this a real invention or just an idea?
So the big takeaway here is pretty simple. You cannot just copy and paste your patent application and send it all over the world. It just doesn't work. Your strategy has to be carefully tailored to the specific legal quirks of each country you want to file in.
All right, this brings us to what is arguably the most critical part of this whole process, actually writing the patent claims. This is where the rubber meets the road. This is where you legally define exactly what you own. You have to get this right. So, what are patent claims? Simply put, they're the fences you build around your invention. They tell the rest of the world, hey, this piece of the technological landscape, this is mine. And they have to be crystal clear, because these are the exact words that will be picked apart by examiners and maybe, one day, in a courtroom. Now, when you're drafting these claims, you run into what I like to call the Goldilocks problem. First, there's the risk of being way too broad. A claim like an AI model for data analysis. I mean, that's almost guaranteed to be rejected for being abstract. You're basically trying to patent a concept, not a specific invention. But then you have the other extreme, being way too narrow. Look at this example. A 5-layer network for finance on Tuesdays. It's so specific, it's almost useless. A competitor just has to use a 6-layer network or, just wait until Wednesday, and they've completely gotten around your patent. It offers zero real-world protection. And then you have the claim that's just right. This one works. Why? Because it's specific about the invention, a novel architecture. It clearly states the technical improvement. It reduces data processing time. And it ties it all to a concrete real-world application, fraud detection. This is strong, it's defensible, and it offers you meaningful protection. So let's wrap this all up. Here's your blueprint. Number 1, always frame your AI as a solution to a real-world problem. 2, focus your claims on specific technical improvements. 3, get into the details of your novel architecture and techniques. 4, find that Goldilocks zone, not too broad, not too narrow. And finally, always tailor your strategy for the key global markets you care about. And so we'll end on this one question. It's really the key to everything we just talked about. Before you write a single word of a patent application, you need a powerful, crystal clear answer to this. What tangible, real-world problem does your innovation actually solve? That answer, that's the bedrock of your entire intellectual property strategy.